This is another video in my series on alternating current. In this video, I'm going to look at the relationship between power and energy. You'll find this topic along with others in my course entitled Basic Fundamentals of AC Circuit Analysis. You can access this and my other courses on my Stand Store at this web address. Energy is defined as the property that must be transferred to an object in order to perform work. Energy equals work. Consider these two weightlifters lifting the same amount of weight to the same height. Both do the same amount of work. Both expend the same amount of energy. In terms of physics, work equals mass times acceleration or gravity times height, which equals 100 kilograms times 9.8 meters per second squared times 2 meters, which equals 1,960 joules. However, the weightlifter on the left is slower than the weightlifter on the right. Hence, we say that the right weightlifter is more powerful than the left weightlifter. Power measures the rate at which work is done. Or that power equals work divided by time. So if power is equal to work divided by time, and we know that the same amount of work is done by each weightlifter because they've lifted the same weight through the same distance, and that is equal to 1,960 joules. But the weightlifter on the left completes his lift in 3 seconds. So the power delivered by that weightlifter is 653 joules per second. The weightlifter on the right, however, lifts his weight in 1 second, so that the power delivered by the right weightlifter is 1,960 joules per second. Because work is measured in joules, power is measured in joules per second, and this measurement is defined as watts, such that the work of 1 joule completed in 1 second is equal to 1 watt. If we watch the lift, we see that the speed of the lift is not consistent, regardless if the lift is completed in 3 or 1 seconds. Some of the lift is completed faster or slower than the other parts, which means the power delivered will vary. So if we use the total time for the lift in our equation, the 1 or the 3 seconds, we define that power, the power delivered, as average power. If we break the whole lift up into smaller time increments, such that the power over that small increment is consistent, we will define that as instantaneous power, which is consistent over that small time increment. In terms of electrical power, the work done, or electrical energy, is the movement of charges caused by the push of EMF. In other words, it is the energy required to move an electric charge of Q coulombs over a potential difference of V volts, and is expressed as V times Q electron volts. By definition, 1 electron volt is the amount of energy gained or lost by the charge of a single electron moving across an electric potential difference of 1 volt. 1 coulomb is equal to 6,250, followed by 15 zeros, electrons. And 1 electron is equal to 1 over Q, which is equal to 1.6 times 10 to the negative 19 coulombs.
Want to charge mess-free? Just snap it. Want to charge all at once? Just snap it. Want to charge doubly fast? Just snap it. 𝐃𝐈𝐒𝐂𝐋𝐀𝐈𝐌𝐄𝐑.
This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also from time to time be reviewing electrical products that, in my opinion, are worthy of paying attention to. This address will give you access to the supplier of aforementioned products, and it is also the connection to obtain a free copy of my 50-page electrical power crib sheets, which will serve as a quick reference of technical calculations that you may need. Also, by providing me with your name and email address, I'll be able to forward you information to connect you with electrical products and to provide you with notifications of more electrical training videos.